Hi, everyone, and welcome to Cloud Native Live for Thursday, September 19th. This is our stream that we do pretty much weekly and sometimes several times in a week to go over basically inside the guts of all the cloud native technology. We get to take a look at how everything works and hear from the people working on it. This is a live stream that is sponsored by the CNCF, and as such, it is governed by the CNCF Code of Conduct, which basically boils down to be respectful for each other. So please be respectful to each other, not for each other. And we just invite you to be civil and kind in the comments and questions, and we invite you to ask any questions you have. We'll be answering those throughout the stream today. And so with that out of the way, let's go ahead and have Andy and Stevie introduce themselves and their topic today. Andy, you want to go ahead?
Sure. I'm Andy. I'm the CTO at Fairwinds, author and maintainer of Goldilocks, Pluto, and maintainer of Polaris as well. I'm also co-chair of the policy working group and a CNCF ambassador. So I just love all things open source and CNCF. And I will hand it off to Stevie.
Hi, I'm Stevie. I am a senior tech lead for our SRE team. Andy's my boss. I don't have a bunch of other stuff to tell you about there. I've been with Fairwinds for about 5 years.
It's okay. A lot of us in the CNCF ambassador space start gathering titles. We start sounding like titles like Queen of Dragons, or stuff gets added on. So
Stevie Caldwell, first of my name.
So great. That's awesome. So anyway, go ahead, guys. Sorry, I didn't mean to.
No worries. I do feel a little weird when I list all those off now because I'm like, it's a lot of things. Anyway,
flex. You got it. Flex it.
Well, today we're going to be talking about ArgoCD. So ArgoCD is not a project that I work on, but it's a project that we work with a lot here at Fairwinds. So we build clusters for other folks and we run them for them. And so GitOps is a huge part of what we do. But interestingly enough, we also build software at Fairwinds. We have a platform that we build and deliver. And the way that we deliver that is on Kubernetes. We use our internal Kubernetes clusters and we run them just like we do for our customers. And for a long time, since we started deploying this software before GitOps was really even a thing, we deployed it in the way that we always had, which was with a pile of bash scripts. And I'll talk about those a little bit more in a bit. But what we realized a little while ago was like, hey, maybe we should modernize our deploy process because there's better ways to do this now that will probably simplify a lot of things for us and make our lives easier and use a lot more common tooling. And so we sat down and wrote out a process for how we're going to deploy our application. So what you'll see today is all demo applications, but it's a very close model of exactly how we deploy our software at Fairwinds. And so we're just kind of going to go through what we had before, what the improvements are, what we were trying to make better, and then how our deployment process with ArgoCD works today. So we can just go ahead and dive in here. Get that screen share going. Let me know when it's ready.
You're good.
Cool. So this is an open source repo that Fairwinds has been maintaining for about 6-7 years, it looks like. I think it predates me at the company. And this is rok8s-scripts. And rok8s-scripts, for its time, 7 years ago, was actually pretty cool. It is a very standardized, semi-opinionated set of bash for deploying things to Kubernetes. So really the heart of it is all of these bash scripts. And they do things like deploy k8s manifests and install the requirements like kubectl and Helm and all the other things. You can do Helm template from here. You can build and push a Docker container. And this is all fairly standardized, and there's a couple standard commands you can use here. And again, at the time, this all worked great. But if you dig in here, I'll just click through a couple of these. Some of the more gnarly ones, like Helm deploy, it starts to become a lot of bash, a lot of environment variables that you have to understand how they work, a lot of config files. And also, if we look at our old deploy repo, Insights release here, how we release our software, it requires even more scripts to do all the things that we want to do that we've added on top of it. And so it's kind of all it's not so much a mess. It's just, it's a lot of bash to wrap your head around. And if you've worked with piles of bash before, they always become unwieldy at some point. And so we said that, let's see if we can simplify this by moving to ArgoCD. So what we have for sort of demo app today. Well, Stevie, first, is there anything I missed as far as like how we used to do things? Anything I should?
No, I mean, I don't know if you want to touch on like you said it was opinionated already, and the importance of like a certain directory structure to get the files to help control your deployment, right? So like if you were using rok8s-scripts, which I will say is an awesome name, by the way, but that it required you to have these specific, files, the specific config files, and these specific directories in order to, actually do what it does.
Yeah, no, I think that's a good point. So we would have this deploy directory, and it was very specific. You had to have, for each environment you wanted to deploy to, you had to have a config file. So like, here's the config file for staging. It says which secrets to pull in, which Helm charts to pull in, what your Helm release name is for those charts. These were a little bit confusing because they're bash arrays. And so a lot of our end users had trouble kind of figuring out when to use a comma separated list and when to add another array element, which was very confusing with Rockets. So you have one of these per environment. And then we have this concept of feature environments where we would, for each feature branch we would open, we would generate a new environment in the cluster, which is a really nice thing. Our developers really like having that because you can test your stuff live in an environment that's very similar to what staging and prod look like. But that introduced, now we have within our config where we're specifying variables, we're referencing other variables. So we're starting to nest variables together. And so this sanitized branch kind of became the name of the things, of the ephemeral branch of all the things in it. And there's a lot of script that I showed that kind of enable that do kind of some workarounds to make that work. And then for each environment, you have a production folder and you have your SOPs files with your secrets in them, and then your values files for the Helm chart. So this is kind of the organizational structure Stevie was alluding to, and it is fairly opinionated. Some of the opinions we still like, though. So we can talk about goals of what we were trying to do. A few of the things that, and I'll just share our outline here so that I can talk through the goals. But some of the things that we should stay the same. So we did have some opinions about all containers should be tagged by the Git SHA that created them. So now we always know which code is running where at any given time, because it's all tied to an exact SHA.
Andy, can you talk for a second about the difference between tagging it with the Git SHA versus tagging it with, latest or a specific, semver?
Yeah, effectively, it's immutable, right? So, the Git SHA is always tied to this, as long as you don't allow like rebasing on your main branch, which you should probably not be doing, then it's effectively immutable. So this container is always tied to this piece of code. And so, we're able to always track it back to the piece of code that generated the artifact. Additionally, we can carry the same artifact through from staging to prod. So we can deploy this container SHA in staging, test it out, and then deploy that exact same container to prod. And that was always a big push for us because we always wanted our staging environment to look as exactly the same as prod, especially, having gone through with clients, we're seeing this bug in production and we can't reproduce it in staging. And we're like, well, what code is where? And they couldn't tell us. And so we said, well, let's move to this process where we know exactly where the code is at any given time.
And there's a security component to that as well, right? Because you can't have, someone essentially sneak in, a nefarious actor, sneak in, an image that's tagged with a different image tag than, sorry. I have young people in my house today. But you can't have someone sneak in an image that's tagged with a previous, version and have it be, have some sort of exploit or something like that in it. Like it's tied directly to that SHA, like you said.
Exactly. Like we did in Clustered, where we snuck an image into the cluster that had the same name as a central container component or a cluster component, but was a completely different container and didn't work at all.
Right.
Yeah. Yeah. So definitely a security component of that as well. So immutable tags and always rolling forward with new ones. So that was a huge part. The second thing we wanted, as soon as we push any piece of code to main, we want to be able to deploy to staging. The other thing that we have is we have two separate repos. We have one for our front end and one for our back end. Obviously, this could apply to a more complex environment where you have multiple services, but we have one front end, one back end, and that's how they are split. And we need to keep that split because we're not going to merge the repos or anything like that. And then we also wanted to keep our ability to deploy feature environments or ephemeral environments, as we call them, because that has been such a huge benefit to our developers. And then right now, we don't automatically release. We release when we decide we want to release, which is anywhere from 2-3 times a week to once a week, depending on the features that we're putting out and things like that, or whether bug fixes need to go out. And we do that just by updating to whatever SHA we want to deploy, what piece of code we want to deploy to the front end, what piece of code we want to deploy to the back end. Obviously, we could be more sophisticated about that, but it's working for us now, and that's how we're going to keep it. So that's the requirements for what we wanted to keep. What we wanted to change, we'd like to be able to do secrets management better. We're actually not going to talk about this today. SOPs works great. We really like SOPs, but as far as updating secrets frequently or changing them, it can be a little bit difficult. And so we will probably be moving to the external secrets operator tied to our vault, but that's not going to be part of the demo today. We wanted to move to a GitOps pull model so that our CI provider doesn't need access to our cluster. Our cluster just needs access to our code. And then we wanted to clean up, all the piles of bash. So we would like to have, use more standardized tooling. We're on Circle CI, so that's what we're going to be using today. There's a lot of pre-built stuff for Circle CI. We wanted to use as much of that as possible. And we... But that also applies to if you're using GitHub Actions or something like that. We wanted to use as much upstream available things as possible, so we had to write as little code ourselves as we could. So those are the goals of what we did, and I will jump over to the app. I think we said it at the beginning, but please keep the questions coming in if you have them. We are happy to answer them. So let's start with, what do we start with? Well, we have 3 repos. We have the backend, which is what we call Yelb app server. So we're using a demo app called Yelb, which I showed here briefly for a second. It's just a voting app. It's been around a while. I use it on a lot of my demos, so you may have seen it before. So this is the backend. So I basically pulled just the backend code into a repo, and then we have our Circle CI config here. Yeah, we also have the UI repo, which is the front end. And then we have the deploy repo. So this would be the analog to the release repo that I showed earlier for our app. And so in the release repo, and then lastly, we have a chart. We have a Helm chart. So this is our Yelb Helm chart. One important thing to note about the Yelb Helm chart is that we have a couple of dependencies. So our Yelb Helm chart pulls in Valkey, which is the new open source fork of Redis, and then Postgres. And so this app has a database. It also has a Redis cache that it needs. And so for our ephemeral environments and maybe our staging environment, probably not our staging environment, but we'd like to use in-cluster data stores so that we don't have to be spinning up a new RDS instance every time we open up a feature branch. But because these are pulled in as dependencies separately, we can just turn them off for our production or our staging environments and reference possibly a Terraform created RDS or something like that outside the cluster, which is typically what we would do. So the chart has the ability to turn those on and off, which is super important. And then in here, just templates for deployments, ingress, a DB migration job, just some kind of fairly standard stuff. We've got a service account, and then a couple of scaled objects for doing auto scaling. We're using Keta. We won't talk about that in detail today, but it is there. So that's the chart. It is just published as v0.1 right now, I think. And we'll talk about that a little bit more. So in the deploy repo, we've got a couple of folders. We have the stable folder, which is kind of like our long-lived environments. Anything that's going to live longer, we've got it in here. So this is the staging application, and this staging application pulls in the Helm chart. I'm using, I'm pinning to a major version and automatically pulling in minor and patch. Since we control the chart, that's fairly safe to do, but something to be careful about there. So the chart would be released separately. As with our main application, this chart is public. So the incubator Yelp chart is here. If you go look at our charts, our main application in stable is actually available as a chart here, because we do offer a self-hosted version of our software. You do need a key to use it, but the chart itself is public so that folks can see how it's being deployed. And so this directly mimics that. So that's probably all I need to say about the chart. So we've got a Helm chart that we're pulling in. We can specify the SHA for the UI. We can specify the SHA for the app server. That's the backend. And then we can also specify an ingress host name. So these are kind of the three main things that need to change between environments. So if we see here, we've got the staging environment, the app's running here. It's got some votes on it. We can use it. It does what it's supposed to do. It's had a lot of page views because every Kubernetes health check shows up as another page view. And that's the staging environment.
I thought everyone had gotten to it already and had been casting their votes. So
they can, if they want to. Yelp.staging.hilghost.com. Feel free to try and break the cluster. It is completely in a sandbox. If it breaks, I do not mind. So I have a load test script we could run against it if you all want. So we're going to deploy that to our cluster. This is all being deployed to a single cluster right now. This demo, I didn't pull in the complexities of having multiple clusters, but it's not that much of a stretch to jump to another cluster. And honestly, this would stay the same because we typically run one ArgoCD per cluster instead of a centralized one. So this would still look the same. We'd just have another cluster pulling in the prod application. And then we have an automated sync policy for that app. So fairly straightforward application. We can go look at the staging application here. So it's been synced. It's auto syncing. If I go change something about staging, which we will here in a little bit, we will see that change. And then next to that, we have the production application. It looks almost identical. I'm not even going to bother showing it. And then we have the ephemeral branches. And this is where we're going to start using the one slightly more complex piece of ArgoCD, which is the application set. So this is an application set which will generate a new application based on some other thing. In this particular case, we're going to do it based on a folder structure. So we have this generator here called Git. It's looking at this exact same repo, the Yelp deploy repo, and it's looking for path features / star.json. And in that JSON file, we're going to have some key value pairs because, that's what JSON does. And we're going to pull those out and use them in the Go template for generating the feature branch applications. So the name is going to be Yelp dash this identifier. The namespace is going to include the identifier. And then when we get down here, we'll see a very similar structure for the Helm chart. But we're going to do Yelp dash identifier for a lot of the things, including the ingress host name. And so we have Yelp dash identifier.feature.hilghost.com. So we'll show that in just a second how that works. But this allows us to create in this feature folder JSON files to define new environments. So this here is a feature branch that is called Suderman Jr. change tagline. That was my branch name. We'll talk about how that got generated in a second. And then it's got different SHAs of the code running on that particular environment. And it was last deployed at this time. And so that will create a feature branch with its own ingress, with all of its own database and everything at that location. And we actually have that running here. So if you look at the URL here, it's Yelb-Suderman Jr. change tagline.feature.hillghost.com. And this is different. This wording here from this says where we vote on where to have lunch, which is a very confusing sentence. And then we have this more confusing sentence that has a typo in it from this feature branch. So just to show how that's getting deployed. I feel like I've talked a lot really fast. Are there any questions? Have I missed anything? Stevie?
I don't see any questions in the chat. So I guess just to quick recap, what we're looking at is taking the sort of directory structure that was in rok8s-scripts. So like the deploy directory and the config.json files and really like, first of all, consolidating those down into that like one JSON file that has all the stuff that you need in it, and using GitOps and the applications and the application manifest and the application sets to kind of condense all of that logic that was in those scripts essentially into something much more, streamlined and efficient.
Exactly.
So I'm really curious to the next part that is, because I assume you don't go in here and manually like update the commit SHAs when you want to, update your when you want to push out a new branch or something like that. So, and you said you were going to get to that next. So where is that information coming from?
Great question, and that is exactly where we're headed. So, like you said, we don't want to just come in here and have to create manually a JSON file to deploy a feature branch. I want that to happen automatically. I open a branch and we get a new one. The nice thing about this is if we wanted to create, just a one-off environment that came from two different, pieces of backend and front-end code, maybe we're doing some like historical investigation, trying to figure out when something was still working or when something broke. You could come in here and just create this JSON file, point it to two different pieces of code, and get an environment running relatively quickly. But for your average day-to-day work, you don't want to be doing that. So if we look at both the app server and the UI, they're going to have almost exactly the same CI configuration. But if we look at the Circle CI config for the app server, you'll see here we're using orbs. And orbs are they're a reusable Circle CI config made by Circle. It's very similar to like sharing a public GitHub action, right? I know actions is kind of all the rage these days, so I'm drawing analogs to that because everybody seems fairly familiar with it. But very similar to that. So I'm pulling in the Docker orb, the GitHub orb, and then we actually have our own orb associated with rok8s-scripts. We're using that just for some secrets management stuff that's internal to our process. And we'll see a little bit of that here in a minute. So let's start with deploying to staging. One of our first requirements was every time we merge code to main, we want it to deploy automatically to staging. So what that really means is that once we merge, this Yelp deploy stable app staging needs to be updated with the latest Git SHA that's on main for each component, right? So if I merge an app server PR, this needs to get updated to the latest. And actually, if we view blame here, we'll see this was automatically committed by Circle CI staging app server to this point. So this is where this happens. This is deploy staging. We're going to install vaults. We're going to reinstall Vault because I had some weird thing that I haven't figured out how to fix yet.
A quick explainer on what Vault is for folks that may not know.
HashiCorp Vault, key value secret storage. That's what we're using it for here. Fairly straightforward in concept, very complex to run. So HashiCorp's Vault for secrets. Thank you. That is a good call out. And then we're going to pull some environment variables out of that. This is where we're going to get like our GitHub token, and we're going to get, we're pushing to Quay here. So we might get our Quay token here. I guess it's pronounced key. Anyway.
GIF. Here we go.
Yeah. That one's actually key's actually like a real word though. So anyway. We're going to install the GitHub CLI. This is from the orb as well. And then we're going to clone that deploy repo. So remember here, we're in the app server repo. We're in the backend repo. We're going to pull in that deploy repo. And then we're going to deploy staging. This is fixed in a PR. It should say staging. We're going to do some git config. And then we're going to use a YQ command to update that SHA to the new tag in that application staging YAML file. So one YQ command and then a git commit and push. This is our entire staging deployment in 6 lines. Before, it was 100 lines of bash doing a Helm deploy, a complex Helm deploy, and parsing values files and all of these things.
Spread across multiple files. Yeah.
Multiple config files and whatnot. And now it is just go change a SHA over here, because it's really all we actually need to do, right? Is to change that SHA. So that's how we deploy staging. And then, and actually we can let's put that in action. So here's the UI. Changes the text here to what I was showing. I'm going to ignore the fact that there's a bug in it right now. And I'm going to go ahead and merge this, because I feel like we've done talking and not enough actual demo. Of course, I actually have to be in the PR, and I have to merge it. That's not me. That's me. All right. So that's been merged. And we can go here and hopefully see. There it is. All right. So the first thing we have to do anytime we go to do this is we actually have to publish the container. So this step is going to build and publish the container. So we're tagging just the main branch with both the SHA and the tag main. Now we only do that for staging. I know we talked about not using mutable tags and only using immutable tags, but we are going to use the main tag just for a little bit of help with our feature branches, which we'll see here in a minute. So let's talk about the feature branch deploys. So we'll go back to our circle config, because this is really the more complex thing, right? Deploying to staging is something, just change the SHA, no problem. So this is our feature branch deployment. And so what we're going to do is all the same stuff, all the vault things, get the vault secrets, and then we're going to configure Git, and then we're going to run a little Go utility that we wrote into the deploy. And the reason that we did this in Go is because we need to interact with this JSON file, the feature config JSON file. And yeah, I could write some bash that uses JQ and modifies this file or creates a new one. But at the end of the day, I also want to be interacting with this last deployed field and generating this timestamp and figuring out how many feature branches we have at any given time, and then sorting them by when they were last deployed so that I can prune out old ones, because we don't want to leave all our feature branches around all the time. And so instead of writing a lot of complicated bash, Go is very good at, actually, I'm going to switch to VS Code here because I think we get a better view. Go is very good at parsing JSON, writing JSON, and dealing with time. Now, you may scream at me for saying it's actually really good at it, but it's a lot better at it than doing it in bash. So we can define that JSON file as a struct here. Very straightforward. We can write some flags into this command, pretty straightforward. I did just a single main.go for this. I did not want to do a complex thing. I just want to go run main.go and modify or create a JSON file, right? And then be able to prune out the old JSON files. So all this does is read in, what exists for JSON files. It can take out the last X number. Like right now we have a max features of 2, so there will only be 2 allowed feature branches at any given time. And so if you may have noticed in the CI config, we run 2 commands. We run the generate command, which says we're going to generate a new feature config. Oh, I don't know what I just did there. Sorry. clicking too much. We're going to generate a new feature file. We're going to use this UI tag, and we're going to use the component. We're updating the UI component. Now, this comes back to a little bit of why we're tagging main. So for any ephemeral branch, any feature branch that is from the UI, we want to update the UI tag to the latest, but we want to use the current staging tag as the default for this. And the easiest way to do that was just to tag staging with main all the time. And so when we create a new feature branch, we just default both tags to main, and then we override one of them to the current tip of the feature branch. So it's just a little bit of a cheat, frankly. There's probably another way to do that. I could go query the Git repo. I could look in the staging deployment file. Maybe that would work as well. Maybe that's a better way to do it. There's probably slightly better ways to do all of this, but really the point was we've consolidated hundreds or thousands of lines of bash into what is 200 lines of Go and a couple lines of bash.
Andy, what other options did you consider when trying to figure out how to like get those files edited, live updated, based on the commits and things like that?
I started with JQ. I did try to do this with JQ, and then I got really tired of it really fast. And I was like, I could do this in like 15 minutes and go.
Yeah.
Why am I doing this? There's probably others out there. Those are kind of the two main ones I came up with. But yeah.
I mean, you're far from the first one, Andy. Speaking as someone who literally spent the last week writing something that probably would have been a gnarly bash script in Go instead. So what I think is good here, like personally, just like watching this, because if people don't know who watch these kind of streams before, like I don't necessarily come into this with full knowledge about what's going on. I know the topic they're all going to talk about, but watching this, I think it's really good for people to see, like, hey, like this is a real thing. Like you had to evolve from, hey, we have this pile of bash and now we've turned it into something. And you know what? Yeah, we could probably automate this and not have this be a Go binary and have something like, yeah, sure. But I think this shows something that's real. I think we're all in various states of this if we're being honest with ourselves. So
right.
Yep. I think it's really good. So I mean, my question's kind of related to that. Like, how you've shown a lot of really cool things to get to here. How did you kind of decide from like, okay, because I mean, we all get to that point when we stare at this pile of code and, our eyes are wide and we're like, oh, what am I supposed to do with this? And how did you make, like, what was kind of the decision-making process that not just got you to this Go script we're talking about, but also like deciding to go to Argo and deciding these things? Because I imagine someone watching the stream later might want to know, like, well, we're in a similar boat. Like, how did you get to here? How did you decide what to do? What was the motivation? Like, what was some of those kind of steps along the way that helped guide you into this structure of things that you come up with?
Yeah, that's a really good question. I mean, for us, like, the decision to move away from rok8s-scripts in the first place to just start looking for an alternative was driven by the maintenance cost. So if you look at rok8s-scripts builds a container that's called CI images, and CI images has a whole lot of dependencies. So if we look in this install Rockets requirements, we install the AWS CLI, we install kubectl, we install Helm, we install SOPs, we install the gcloud utils, we install, I mean, this container ends up being like 1.5, 2 gigs when we're done building it, because it has all these dependencies in it. And all of these dependencies have CVEs. They all change versions frequently. I mean, you can see right here, we're not on the latest version of anything right now. And this is the latest version of Rocket8s-scripts, because it takes a lot of effort to update all of these individual tools. And then when you're packaging them all into one container, just the maintenance cost of keeping up with Rocket8s-scripts is far too high. And whenever something, it's been pretty stable as far as the actual bash goes, but if we want to add a new feature to it, somebody has to go and remember how all this bash works. And, those people are becoming very rare because they've all left the company. I'm probably one of the last few people around. Maybe, Stevie's worked with it quite a bit as well. But it's probably just the two of us at this point that know how it works. So the cost of maintaining all of that versus using upstream got to the point where it would be cheaper to rebuild in something new. And then from there, we were already using ArgoCD and GitOps to deploy all of our other things in the cluster. So I'm just showing you this team on ArgoCD, but every single component in this cluster is deployed via ArgoCD. So we've got, all of our metric server, our ABS CSI driver, load balancer controller, the add-ons in this cluster were already being deployed via ArgoCD. So we're already maintaining an ArgoCD installation. Why not extend that to deploying our applications as well? It was just kind of the best logical choice. So that's what led me down the path. And then it was just, okay, now I have to solve the problem of how do we actually make this happen? So I hope that helps.
It does. Thanks.
Cool.
Back to your regularly scheduled programming, everybody.
Awesome. So really at the end of the day, these two commands right here, they just create a new feature JSON file, and then they prune any old ones. So we could show this off. Well, let's go watch our previous run here. So we published main, we did deploy staging. So you can see I've got a git diff in there. We can see we updated the staging commit. So the latest UI in staging by this time, oh, it hasn't been deployed yet. That's too bad. Let's find staging and force it to sync. Surprised. Anybody remember what that 4E4A.
I mean, we probably all have we should, instead of, there's like the swear jar, we should have the every time I've had to look up a Shaw jar, because I feel like you could donate to many good causes with that.
Interesting. I don't know why this is. There we go. There's my typoed version. It's probably just cached. Or maybe I just wasn't paying close enough attention because it was zoomed out. But we have the typoed version now here in staging. It has been deployed. And it is here. I just can't see it. Anyway, that's our staging deploy. So now we're going to go back to our UI repo. We're going to pull the latest version of main, and we're going to go fix said typo because that's not great. All right. And please vote on where you would like to have lunch. Sure, that's fine. We'll fix the typo. We'll check out a branch. So one thing you may have noticed is that I said we can deploy any tag of the UI or any tag of the app server, the backend, to a feature branch. But what if I'm working on a feature that requires both backend and front end changes, right? Because sometimes you need to create new endpoints that the front end can consume, right? So what you can do in that case, we've written that generate script to handle that situation. So let's go ahead and get this branch going. All right, so what did I forget?
I don't know if this is just me, but Andy, maybe clear the screen because I think the Andy Suderman tag is covering up your typing for me.
Sorry. There we go. All right, so we have pushed a new branch, and it is currently building. So yeah, sorry, I have tmux going here, and it's probably too many tabs. We can get rid of that one. There. So that one's building. We can watch it build while we work on this side. So now we've got, say we have a backend change we need to make. We can check out a branch of the exact name. So get checkout branch typo. I'm going to actually, yeah. I'm just going to make an empty commit because I don't have any backend changes that I need to make. And what we should see is eventually, once these build and complete, is in our deploy repo, we should see a feature branch called Suitor Junior fix typo. And it's not a UI tag and then the main tag for app server, but it will have the UI tag and the app server tag that associated with the same branch in both places. So that'll allow us to test both of those components together rather than testing the branch UI against the staging backend tag, basically, or the main backend tag. So that's the last piece. And that's going to take a minute to build because if we look at the UI, looks like it'll take 5 minutes or so. In the meantime, what else can we talk about? One thing we haven't done yet, and I need to work on, ArgoCD application sets do not clean up the namespace that they created for all the applications. So if we look inside of our cluster, we'll probably see a few of these Yelp. I think I cleaned them up yesterday, but these will start to stack up because the namespace won't exist anymore. But the namespace will still exist, but all of the contents of it will be empty. Everything will have been deleted out of it. So that's one thing to take a look at. I've started labeling the namespaces so that we could easily write a script to clean them up and maybe just run that as part of each deploy. In fact, I have this horrific one-liner here for finding empty feature namespaces. So that's something that we need to work on. And then also, there's no concept of deleting the feature branch once it's been merged. So this feature change tagline, for example, doesn't exist anymore, this branch, but the feature branch is still there. So that's something to look at. It does look like one of our deploys just completed. We can see we're deploying feature. I think I accidentally broke the naming here. This should have the feature branch name in the commit message. But we have this new feature branch. It was added 1 minute ago. And notice that one of the others just disappeared because we have a maximum of 2. And so we just deleted that old main whatever, I think it was called modify header. You can see that that's here. And so that file's gone. It's been replaced by a fixed typo. And right now it only has the app server. So it looks like the app server build finished really fast. That makes sense because I didn't actually make any changes. So all the container was probably cached. And so in a minute or two, once the front end finishes, we should see it pop up here as the UI image tag. And then ideally, if we look here and we go to applications and we sync this one and we filter down to projects team 1, we should see at some point, and this one will disappear. That's the one that's been deleted. And then we will see the fixed typo one. So another downside that I've noticed, I will say our deployments are actually generally faster than they were previously. Because, yeah, you can see now here it's deleting the modify header one, adding the fixed typo one. The deployments are a little bit quicker because making that git change is super fast, and then ArgoCD will pick it up within a couple of minutes. Whereas the Helm deployment thing was not the fastest process that we could do. And we were using the weight and atomic flags, and then I think we were also we had this bug where we had to like delete the Helm release and redeploy it because of some of the dependencies we were using. And with this process, it's really just waiting for ArgoCD to sync. The second thing is I can give this dashboard to my developers. And so now they have this nice way of seeing how their deployments are progressing, rather than going through and scrolling through thousands of lines of bash running in Circle CI, trying to figure out what happened with their build. So, obviously the Docker build's still over here. So if something happens in that particular place, that's still something you'll have to deal with. But as far as deployments go, everything that you might need to know is here in ArgoCD, and I can give them access to this dashboard. I can put it behind auth, and they can see how that goes. So that's something I'm a big fan of. We could see in this modify header namespace, if we look for pods, there's nothing there because that branch or that config JSON was deleted. And the application sets don't clean up the namespaces. But here we can see in the new fixed typo namespace, we have almost everything running except for this one last val key replica. So if we take a look at this one and we take a look at the ingress, hey, look at that. But it still has my typo. Live demos. What was I thinking?
Something caching a hard problem, something.
Yeah, something like that. That's interesting because I thought it was deployed with the new SHA. So 41CA, and this is details, parameters. Oh, UI is still set to, it hasn't updated yet. I just need to sync this app. That's the other thing that I've noticed is that application sets forcing a sync. I haven't looked into this super deeply, but forcing a sync is a little bit different and can take a little bit longer. I do have webhooks from GitHub back to ArgoCD to trigger a refresh whenever we merge a change. But that does still seem to take a couple of minutes with the application set for it to pick up changes in the Git repo. So something to be aware of.
You mean versus just the application? It's just application,
right? Yeah, yeah. The generator. I haven't figured out how to force the generator to go pick up the new files immediately. So it's a minor annoyance. At maximum time is 3 minutes is the standard sync cycle on ArgoCD. So and here we go. Our typo is fixed. So I'm happy to see that. That is the majority of the demo. I could go deploy prod, but that's just a manual change at the moment, like I mentioned earlier. So I'm not going to do that. And yeah, what other questions do folks have? Have we gotten any questions?
No. I mean, Technobabble co-signed your use of Go. Said any object-oriented language is going to scale better than Bash. So
yeah. I mean, that's the other thing too, is if this starts to if this Go script here begins to balloon, I need it to do more and more, I can pull it out into its own repo, and I can then start building it as a binary that we pull into these builds rather than doing Go run. And the tooling is all there. We have standard ways of building and releasing Go binaries. Maybe it turns into a sort of generic tool for managing our deployments, and it gets pulled in. But starting with Go here, the scalability is big.
So just an opinion question for you. I think it's pretty standard to want a CI/CD process that deploys releases to your staging environment and your feature environments. Do you ever? Usually people don't talk about doing that with prod and releasing automatically to prod. What are your thoughts on that?
There are people out there who do it, right? It's doable. It really, that's a big process and culture question, right? Mm-hmm. What does your internal process look like? what is your culture around testing your own stuff, writing tests for your stuff? How confident are you that changes that are, that make it to a certain point are safe to deploy to prod? How good are you at core, like how tightly bound are your services, or tightly coupled are your services, right? If I make a change in this service versus this service, or just in this case, front end and back end, how tightly coupled are they? If I make a change in the back end that might break the front end and I'm releasing them separately, well, I can't automatically deploy to prod then, right? I need to gate that. So there's a lot of underlying questions to answer about that before you can say it's safe to do. I think if you can get to a point where you're confident in that, great, go for it. Deploy continuously. I think we're actually pretty close to that. And if we were to, to do that, I'm not trying to think of how we would do that in this process. I'd have to think about that more. It's been in the back of my head to consider how we might simplify the release process, like maybe just down to a tag, right? Where we tag the UI, we tag the back end, and then they both get deployed to prod. But yeah, I don't know. It's a great question, and it's as much a philosophical one, I think.
Yeah, for sure.
For sure. Practical.
Well, at the stage that this is now, what future work do you think will be needed to make this, to implement this? Like, here, this was the exercise, right? Thinking about how to do this with our own internal application, so our own internal software. So what are the next steps, do you think, for making that happen?
I mean, we're pretty darn close. We need to figure out how to, I would really like to delete feature deployments once they've been merged.
Yeah.
Because it really just doesn't make sense to keep these around. Although maybe just having the time-based pruning is good enough, and we just leave that, the max number. I have to look at that. And then migrating all of our secrets from stops to external secrets operator will be the next big step.
Yeah.
So secrets are always going to be a problem, but especially so in a GitOps world. Previously we used rok8s-scripts and SOPs, which encrypts them directly into the repo, which is actually quite nice. And I believe there might even be a SOPs plugin for ArgoCD. I'm not sure, to allow you to still do that. So we might be able to just keep our existing secrets, but I'm a big fan of the secrets operator, and then moving our secrets into Vault. It makes them a lot easier to rotate, which we do fairly regularly. So it is nice to just be able to go into the Vault UI and be like, nope, I'm rotating this secret here.
So one of the other things I like to ask here too is just any calls to action you have. Are there things you want people to try out? Are there things or resources you'd recommend they read? Any of those kind of things would be good.
Oh, can we kill the screen share? Sorry.
I got
forgot
you.
I'm on one monitor here. Anything that's just reading? Nothing in particular. I think if you're not familiar with GitOps and not, considering how that might improve process for you in some place, if you're not familiar with that, it's a great thing to learn and to go get familiar with. We started out deploying our infrastructure add-ons that way, and we do that for all of our customers, and it's just been a big game changer for us. It introduces a lot more stability and a lot more, in a customer relationship, we have customers that like to try to break things, right? By going in and, deleting stuff or changing things in the cluster, and the constant syncing of a GitOps approach really saves us a lot of trouble there. So that's one huge benefit. If you're still writing a ton of Bash and you want to learn Go, highly recommend that.
I can second that.
I won't advocate for any particular site or anything, because there's 1,000 classes and books and whatnot out there, and everybody learns differently. But yeah.
And I would also encourage people to use those links and get the repos and try it out yourself. Try setting up, your own test bed and seeing how that looks in real life. There's obviously some other stuff you have to get going, like you have to set up ArgoCD and stuff like that. But if if you have it, it's good to do.
Yep, for sure.
Awesome. Well, anything else before we go ahead and wrap up?
Andy, there's one last question I meant to ask you. Sorry. So I've been hearing that astronauts really enjoy computers. Do you know why?
No. Why?
I think it might be because they have space bars.
Gotta end with the pun. Gotta end with the pun.
Oh, always
Awesome.
love it, Stevie. Always love it.
Well, thank you so much for coming today, Stevie. Andy, thank you so much. This is really great to just see something very practical. I think very real, like I said, for many people who've gone through this. So, anyone's welcome to go view this again and check out all the different links and things that they were demoing. And